Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back to another session of Artificial Intelligence. In this today's session, we are going to learn image classification using CNN with Python. Let's see the overview. Image classification, we'll see the program, how we will classify the image using Python programming. Okay. So here, image classification, what is image classification? Which means the system will take the image as a pixels and it will identify whether that image is having cat or dog. Like that, it will classify that image with the observing the patterns and edges, features of that image. It will classify that image as a cat or dog, etc. Okay, so here we will train that model in the way that it will classify that image, whether it is a spam or not, email filtering, like that. It will classify the images categorical, either it is yes or no. Okay, let's see. To do that image classification using CNN with Python, we are already aware of what is a CNN, what are the layers are involved in the CNN to classify the image. So here the first layer is input layer, which will take the image as an input and it will convert into the pixels. After that, there is a convolution layer. This one is a very important layer which will extract the features of that image, important features, shapes, edges, all those things will be extracted in the convolution layer. After that, there is a pooling layer. Before that, there is a activation layer which will apply some activation function, RELU, TAN H, or leaky, like that. It will apply some activation functions. After that, it will goes to the pooling layer. That feature map, whatever output is there, that will goes to the pooling layer. In that pooling layer, it will perform either max pooling or average pooling. Maximum, it will uses the max pooling. And why it is used? Because it reduces the feature map to train the model efficiently. If it is the less amount of data, the training is simple, and it is also reduces the time also to train the model. So it will reduces the feature map dimensions. We will use the pooling. Okay, and it will keep only the important feature, important things about the image. After that, there is a dense layer, fully connected layer. In this layer, it will connect each neuron with another neuron. Next, the last one is output layer. That layer is called as the judgment layer or prediction layer. So it will predict the output, whether it is classifying the output, whether it is a cat or dog or a crow, like that. It will classify the image, whatever in the input layer is given, it will classify in the output layer. In that way, it will execute. So let's see the how the Python programming is implemented. So first, we already in the previous session we have seen the various Python libraries. One of the libraries is TensorFlow, which is used to perform the mathematical operations, complex mathematical operations. No need to write the logic to do that. Just we will give the values and it will perform the mathematical operations, complex operations. So here there is one more library called Keras, which is also used to perform the mathematical operations based on the formulas. Okay, so here importing the libraries, whatever required to train that model to classify the image. First one is TensorFlow, next Keras. Keras will work on top on the TensorFlow. There is a sequential, means initially it is empty, it is ready to add the layers into that. So it is imported later. There is a convolution 2D, and we are doing max pooling, flatten, and dense, fully connected layer. Okay, starting initializing the model with the sequential, means the model is ready to add the layers one by one. Okay, next add convolution layer. This one is a very important one, I already said. So which is used to extract the features, important features of the image, shapes, patterns, edges, all those things will be extracted from that image. So add convolution 2D. This 32 means filters. 32 filters will be applied on that image. 3 by 3 is the kernel or filter. Okay, activation function is RALU, means which is used to replace all the negative values in that matrix. Next, padding, to keep the image size in the same. If you take the pooling, then it will reduces the image size, the feature map size. That's why here there is another one that is called as a padding. The value is the same, which means it keeps the size of the image same as the input image, that is 32 by 32 or 64 by 64. It will keeps the same. Okay, input shape is 32 by 32 by 1. So means 32 by 32 image width and height, and 1 is the grayscale. If it is a 3, then it is called as RGB, 3 channels. If it is 1, means grayscale image. Next, adding max pooling, means to reduce the image. Here we are using the max pooling. So if it is a 64 by 64 image, then it will be reduces to 32 by 32, because it will take the max pooling with the 2 by 2 2 stride and a 2 by 2 region. It will take first 2 by 2 region, second 2 by 2 region. In such a way, it leads to the 32 by 32 image. If it is 64 by 64 image, after performing max pooling on that feature map, then the output is 32 by 32. Okay. Next, adding convolution 2D for 64. Like that, I said 64 by 64, 3 by 3 kernel. So 64 filters. Activation layer is the same, RALU, to replace all the negative values. Padding is to retain the same size of the image. We have taken padding as same value. Okay. Next, again, max pooling, means multiple times. First, the image 32 filters, applying the 32 filters. Next is 64 by 64. After that, 128 by 128. Why we are going in depth means, if you go in detail, then there is no chance to miss any detail of that image. Whenever you train the model with the more samples, then it will give the accurate result. If you reduce the size of the samples or features, then automatically it will lead to some wrong results or bias results. Okay, that's why if you want accurate accurate result, then we need to train the model with the more samples, 32. Then it will give some of the accuracy. Next, if it is a 64 in detail, if it is a 128, it will give more details about that image. Okay. Next, flatten output. The last this flatten is the last technique which will apply to that feature map. After that, there is a dense layer. In this layer, each neuron is connected to another neuron. For example, each and every region is connected with the another region. If it is a entire image, then the each one will be connected to another one. Says that, okay, this region is connected to this region, then it will form some ear or some nose or some eyes. Then it will remember all those patterns after training. So in this flatten also, it will convert, this one is also most important, it will convert that into single vector, so that it is easy to connect each neuron in the dense layer. Okay, so here it is 64 and activation layer is performing. I already said to remove all the negative values in the feature map. After that, here 10 neurons, and activation is, means if it is a multi-classification, then it is a soft max. Later come optimizer. There is a ADAM is the algorithm which is used to optimize the model. Next, categorical cross entropy, to reduce the error and to know the accuracy of the model. After that, print the summary of that model, means how many neurons, how many times it is performed, like that. Let's look at here the total parameters, 674, trainable parameters, non-trainable parameters. This is the summary of the entire model. Like this, it will first convolution 2D, then the size is 32 filters, and the parameters is 320, like that. Max pooling 16 by 16 after applying. Next again convolution 16 by 16. Later after applying max pooling, it will reduces to 8 by 8. Again convolution on 8 by 8. Next flatten to convert into single vector. After that, a dense layer, it is connected to each and every neuron, each and every region with another region to observe the patterns of that image. Then in the output layer, it will predict whether that image is a dog or cat. It will give the output in the output layer. Okay. So this question is given 10 marks in the last previous exams. It is very important, a very simple program also. First we need to import all the libraries. After that, initialize the model with the sequential. It is ready to add the each and every layer. Later we need to add the convolution layers multiple times to prime that model. After that, applying the max pooling. After that, flatten. Next, dense. Okay. Finally, printing the model summary. So in this session, we learned the image classification, using Python. Thank you.